We welcome you to the Glass Academy webinars 2022-2023. The theme for this year is Ideas in Architecture. I for Innovation, D for Design Thinking, E for Emerging Trends, A for Around the World, and S for Sensibility. Today we have with us architect Siddharth Thyagarajan. He is a senior project associate at World Resource Institute India within the urban development team at the Sustainable Cities and Transport programs. His work focuses on urban placemaking, street safety and design, nature-based solutions and transit-oriented development. Prior to this, Siddharth has worked on projects within varying scales and typologies such as master planning, urban design, climate responsive architecture, and community engagement across diverse global contexts such as India, Tanzania, Ethiopia, Belgium, and Portugal. He holds a master's degree in architecture and urbanism degree from KU Leuven, Belgium, where he focuses on studying resilient and sustainable strategies in the urban environment, and a bachelor's degree from Ayujan School of Architecture, Jaipur. His master's thesis under the Streetscape Territories program was based on formulating development strategies for the largest recycle market in Merakato district, Addis Ababa, Ethiopia. And with this diverse global work experience, architect Siddharth will share information on passive design building strategies, lessons from Europe. Welcome. We are delighted to have you here with us, and we are looking forward to your presentation. Over to you, Architect Siddharth.
Thank you so much, Priyanka and Team Ethos, for having me on board. So I'll start. Good evening, everyone. In today's presentation, I shall be taking you through the different strategies and the principles through which Europe looks at designing its buildings passively. This presentation is from my learnings and understandings of having worked in Belgium within Europe for a period of 3 years. And I'd like to share these with you today. So to begin with, I think it's important for all of us to understand what really is passive design. So passive design is basically design that works with the local climate to maintain a comfortable temperature in your building or in your home. Uh, Working with passive design allows you to eliminate the need for additional heating or cooling, and it allows you to have more thermal comfort in your homes, reduce on your greenhouse gas emissions, and accordingly also have lower energy bills. So as we look at passive design, it's important to understand that what are the different components which allow for your building to be designed passively. So as we can see here, orientation, thermal mass, which is the materials through which you actually build your building, insulation and glazing are four components which allow for you to use natural sources of heating and cooling, such as sun and breeze, and also prevent unwanted heat gain and loss within your building. Now, passive design is something that is can be implemented across different parts of the world. So it's very universal in its context and its application. But let's try understanding this from the European context today. So this presentation basically focuses on what passive design and architecture is from the Western region of Europe, specifically from the countries of Netherlands and Belgium. Um, a quick glance at the climate profile tells you that what we're looking at is a country where you have cold temperatures throughout most parts of the year, and also you have two peak months of summer. So what buildings need to be designed in this particular region according to this specific climate profiles. Now, what is really the need for building passively within these two countries, and why is it that these two countries are really pushing for passive design within their buildings? It's been understood that 40% of the total energy that is consumed within Europe is through the building industry, and housing is basically takes up a very large chunk of this. So, designing passively allows for buildings to use lesser energy, which in turn also reduces the amount of carbon dioxide emissions that you release into the atmosphere. Having said that, we also understand that energy is probably one of the biggest important drivers for promoting passive design, passive strategies for building. But climate change has also really given the necessary push for developing, for building sustainably. And, the geopolitical crisis of the Ukraine and Russia war has also put a lot of stress on energy within Europe. So, there is a greater onus on all countries to encourage building strategies which are low energy in design. So now that we understand that there is a certain need for building passively, but how is it actually being promoted within Belgium? So the first thing that they actually did was they tried to bring more policies and bylaws. So for example, Brussels being the capital of Belgium became the first city in 2015, which has made it part of its policy that mandates all new construction in the city to be passive. They're also laying greater focus on sustainable forms of construction and refurbishment of old buildings. Secondly, what they're also doing is they're trying to restrict any new forms of construction and on urbanization, uh, because they want to actually restrict the loss on ecology. And simultaneously, they also are encouraging the retrofitting and refurbishment of old buildings through passive strategies. So, in a way, again, giving that necessary push for passive forms of construction. And finally, a lot of financial incentives, for example, of 1 billion euros has been released for the renovation of existing buildings. And a lot of tax benefits, for example, if you choose to build sustainably, you get a 30% decrease on renovations. And similarly, you get a lot of subsidies on buying materials for building or renovating your houses sustainably. So, here we come to nearly zero energy buildings. So while we're talking about passive buildings, then what is really nearly zero energy buildings? So within the context of Belgium and Netherlands, the terms nearly zero energy building and passive buildings are sometimes used interchangeably. But there is a small distinction that I'd like to, make here, that what does a nearly zero energy building even mean? So a nearly zero energy building must have a very high energy performance. So what do we mean by that is that in general, its consumption of energy for its functioning should be very low. And the way in which it is actually constructed, the loss in energy, for example, if you're cooling the building, then the loss of cooling, or if you're heating the building, the loss of heating should be very low. And whatever energy is being used within the building, it is basically offsetted or substituted or covered by energy from renewable sources which are produced on site. I'm going to be explaining this in a little more detail in the next coming slides. So as we had understood in the first slide that what passive design strategies are as orientation, insulation, glazing, thermal mass, solar radiation, and natural ventilation. So these are how you build passively. But for example, when you combine them with active design strategies, which is mechanisms or engineering, which you implement or bring into your building to make it more sustainable, such as, for example, a mechanical ventilation system, an electrical or a lighting system, a chiller or a boiler system. When you combine your passive design strategies and active design strategies, you get these hybrid design strategies, which makes a nearly zero energy building. So A nearly zero energy building is a combination ultimately of passive design strategies and active design strategies, which can be understood through this graphic. So what we see here is that while this particular building has been built passively by having insulation and, for example, the kind of glazing that you have used, uh, but simultaneously they've also tried to install solar panels, and similarly they've tried to also capitalize on geothermal heat, and the idea of having wind power or fuel cells within your own building to actually offset that extra energy is what brings you to a near zero energy building. So while we understand nearly zero energy buildings, I would like to bring our focus on what the passive component of that is, which is passive building principles. So if we look at Europe, um, what are the different principles of a passive building? What are the five principles that one needs to understand to be able to call a building passive? So the first principle is having an adequate ventilation strategy. So, because we understand that while we want our building to respond to the local climate, uh, the building also has its own microclimate. So, for example, when it is cold outside, you want your building typically to be heated. But to ensure that your building also has good living conditions, it is important to have a good, adequate ventilation strategy, which also helps recover heat. The second principle that one needs to take into consideration is that your construction needs to be absolutely airtight. So, for example, if you're cooling your building or if you're heating your building, um, we need to make sure that there are minimal losses through any gaps or through any leaks which prevent any form of energy loss. The next thing is no thermal bridging. So what exactly is a thermal bridge? A thermal bridge is usually created when, for example, you have two different materials on your facade which kind of come together. So, for example, if you are building a wall and your wall is made of brick while your window is made of glass, uh, these two materials basically, when they come together, uh, they have different degrees of conducting heat, and because of which there can be loss in energy. So we have to make sure that we can counter this by working on the thermal bridge. The fourth thing is we have to look at how we do our glazing. So glazing is a very, very important component of our buildings, and it is also, if not done properly, it can also lead to a lot of energy loss. So working with glazing systems that prevent any loss of energy, but also bring in the amount of light that is required within the building is very important. And the fifth important principle that one needs to look at is quality insulation. So insulation is a very important component to prevent any form of heat loss or heat gain as well during summers within a building. So now we'll start looking at each of these principles of passive building in a little more detail. But before we get on to that, it would be interesting to understand, that how does energy loss in a building even occur, and why is it that we are particularly focusing on these five components, which we say are the five principles of passive design. So if you look at this particular diagram, if I were to heat or cool a particular building, then 30% of the energy loss is from the roof. So, for example, if the roof was not insulated, or if there were some air leaks or air cavities on your roof, that means 30% of your energy is actually lost. Similarly, 20% of your energy loss is through ventilation, 15% through your windows, 20% through your walls, and 5% through your thermal bridges, indicating that that integrating passive design strategies into your building to prevent energy losses extremely critical. So we begin with the first principle, which is mechanical ventilation with heat recovery. So what I'm going to be taking you through is how these passive design principles are actually implemented, or how is it that they're translated in the Belgian context. So one such strategy for ventilation, what takes place here is that they use heat pumps. So typically in our countries, where, for example, we use air conditioning, or in the winters we use electric heaters to heat our buildings, they're very highly energy consumptive. But one thing that has been mandated and is becoming extremely popular in Belgium is using heat pumps for cooling and heating buildings. And how they typically work is that they rely on external electrical energy very less, but they take heat from the air, or they take heat from your groundwater, from your ground systems, or they take heat from a surrounding, or uh, chilling from a surrounding water body. And using the principles of compression and evaporation, they're able to heat or cool your homes and simultaneously ventilate them. This is a little complex. I mean, what I'm just presenting is the idea or a gist of what the idea is. But of course, um, you can definitely read about this later, or reach out to me if you would like some more information. The second principle is insulated glazing. So, how does insulated glazing perform? So insulated glazing is where you have typically two or three layers of glass within a single panel. So you basically create a sandwiched panel with an inert gas between each panel, such as argon or krypton. And this inert gas basically acts as your insulating material. So apart from insulating it against the external temperature, insulating gas, these windows are also very good for acoustic insulation. Some things that three components of insulated glazing which are interesting and probably one should know about is SHGC. SHGC indicates the solar heat gain coefficient, which indicates the amount of heat that uh, is actually brought in through the window. And the higher, in a colder climate, the higher it is, the better it is. The U value is the amount of heat which is lost and by the entire window section. And the lower your U value, the better for it. And VT is talks about the visual transmission, which means that the higher this number, then the more amount of visible light that you get in. And similarly, the higher the number, the better it is. This diagram actually shows you, for example, that what would the difference be between the external temperature and the internal temperature if you chose a single glazing system versus a double versus a triple. So, for example, if the outer temperature was 0 degrees and the inner temperature was 20 degrees, if you use a single glazing system, the temperature difference, I mean, the loss would amount to a total of 5.6 degrees Celsius. But for example, if you use a triple glazing system, even with all the energy loss, it would still be able to maintain it at a temperature of 18.5, which indicates that you just lose 1.5 degrees as a part of energy loss, indicating how performative a double or a triple glazing system can be. These are some details which basically highlight, how insulated window sections typically work. I wouldn't go too much into detail, but I'll just point out that so if this being your uh, building structure, which is your concrete, and this is your outer facade. So what you would typically have is insulation between your external and internal part of the building, and this insulation would directly be then connected to your insulated window section. So this is what we're seeing it in the section, and this is what we see it in the plan. And it is a mandate that all new buildings use a minimum of a double glaze section for uh, minimizing energy losses. Um, this we can also see in a photo taken from a site over there. So you have your triple glazed window section over here, and you have your wall over here. Between the both, you have insulation, and what you have here is some bit of a vapor barrier. Now we come to our third principle, which is quality insulation. So insulation is a very, very important component of all your buildings, and insulation doesn't just perform for uh, buildings where you want to retain the heat, but it also works very well for hot temperatures as well. Where for example, if you're cooling your building and you don't want uh, the losses of cooling, insulation works well in that way as well. Typically, insulation is done in every external surface of your building. So you would insulate your roofs, you would insulate your walls, you would also insulate your ground. And what I have indicated here is, for example, a typical par- uh, terrace parapet detail where this wavy line that you see is basically your insulation, which has been indicated also by the blue line. Similarly, the idea is that you always have a continuous line of insulation. So, for example, if you were to draw insulation or design insulation for your building, how would they would typically say is that you take a pen and you draw a line all around your building, and that's how the insulation needs to follow. Uh, uh, any break or any discontinuity in your insulation means that that is a point through which energy losses can take place. Some site images to show you what insulation looks like. So what you see here is through the brick is the external facade, and what you see and these silver or these these panels over here are your insulation panels, and then what you see on the inside is your internal wall. Similarly, the wall, like I said, is not just insulated from the front, but you also typically would insulate your wall from the bottom, so that there are minimal energy losses when the wall actually meets the slab below. So the fourth principle is airtight construction. Now, why is airtight construction important? So what typically happens is when, for example, we install a window at a wall, there are some small gaps or leaks which might come in because of an uneven surface, or you know some mismatches in your construction, and these little points become possible areas where you can have a lot of energy loss. So airtight construction becomes an extremely important component of designing your buildings as well. So for example, in this case, as you see that this is your window section, and this is where it meets your wall above. All these black dotted lines, as I've indicated, wherever you have two materials which meet one another. So for example, where the window meets the insulation, where the insulation again meets the wall, we always put a vapor barrier which allows for uh, the which allows preventing any losses of air, like heated air or cooled air from the outside to the inside, and also prevents any vapor from escaping or going into your insulation. Similarly, you can see this over here as well, and this has also been explained in this image. So for example, here is where you have your window section, and what you see as this sheet over here is your vapor barrier, which prevents any loss of energy through the gaps. The final principle is thermal bridges. So what exactly is a thermal bridge? So if you look at a typical building here, and if this was your balcony, which is the exterior of your environment, and this is the interior of your building, this would be a cooled environment. And what would usually happen is that this does not work well, because if you are heating your building from this side, any cooling, all the the cold environment would basically result in energy losses, because what would happen is your slab, which is continuous over here, would uh, take in all the cold here and take it inside this. So the way we typically construct to prevent this from happening is that we design the balcony as a separate unit. We design the indoor unit as a separate unit, like what you see over here. And in the middle is what we give is an insulation to give a thermal break. So what would happen is that if this space was heated and if this space was cold, if the cold air basically cools up this particular slab, it would not be able to pass through this insulation, and then this space continues to remain warm. So that is how a thermal bridge uh, typically works. So, I mean, these are five basic principles which one would typically follow to design passively. Of course, I mean, now looking at the kind of technologies and developments, I mean, uh, the 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 market, or the entire concept of sustainable construction is far more evolved than what I have actually showed you today. But the idea is that this is just to introduce you to the idea of how different countries approach the entire idea of energy efficient construction. And this is also important to understand that not no one principle works in isolation. I mean, in each detail or each component, you see that all these elements come together. So for example, even in a uh, typical building, you would have your energy, you would have your double glazed windows, you would have your thermal bridge working with that. Similarly, you would have your insulation coming in the right places. So all of them working together can uh, help you design what we would call as a passively designed building. So that brings me to the end of the presentation. Thank you so much.
Thank you, Siddharth, for the close-up insights into the concepts of sustainable design in European context, particularly with the focus on Western Europe. I'm sure our viewers have a lot of takeaways from your presentation and must be curious to know more, including myself. I would like to take this opportunity to ask you a few questions. So, the first question is, while environmentally it is clearly everyone's responsibility to move towards passive design solutions, how would one combat high cost incurred in realizing the passive or home building?
Okay, so that is a question that one gets asked a lot. That if I were to design passively, it means that I need to spend on extra components, such as insulation comes at a price. Similarly, a double glazed window or a triple glazed window would cost a lot much more than a single glazed window. So, the response to that would be that, of course, the initial expenditure that you would make on your building is definitely high. But if you look at this in the long term, the costs that you would be saving in your energy bills, uh, that is something that you can definitely recover over a period of 10 years, because people don't realize, or they don't do the math of how much is it that you're typically spending on actually heating or cooling your building. So that is definitely one thing. And the second thing is that within Europe, and I think this is something that has been catching up in India as well, is that there is a greater incentive from the government to actually build sustainably. So for example, like I had mentioned, you get benefits on you get rebates on your taxes. So that is one financial benefit that you have. Similarly, they also ensure that if you were to build sustainably, the materials would be at a subsidized rate, or they would also suggest that maybe they can also give you some bit of a discount on your energy bills as well if you live in an energy efficient house. So of course, maybe the initial cost is definitely a little high, but over a period of time, I think it all evens out. Yeah.
Yeah, correct. That's true. Moving on to the next question. How relevant are concepts of insulation and airtightness in Indian context?
I think one thing that, of course, when you look at a European context, and typically the Western European context, climatically, we are definitely quite different because what you experience over there are the colder months, while most of India faces, is, has a, is more of a tropical climate. But having said that, I still feel that a significant part of India also does experience winters, and more so, it experiences extreme temperature. So you have extreme heat in the summers, and you have extreme cold in the winters. And I think insulation is something that works well with both. Which and so this is a misunderstanding that insulation is something that needs to be only done for cold climates, but I think we sometimes tend to forget that back in the olden days, we used to even our traditional forms of construction to prevent heat gain within buildings was to build really thick walls, uh, with stone masonry or brick masonry. And I know that we can't afford to build the same way, but the entire translation of that idea would be that you incorporate that, or you bring that in through insulation. So I think insulation and airtightness is very, very relevant, and I think this is something that people definitely need to start exploring and start talking about more, because that is one definite way in which we can really look at reducing how much energy our buildings really consume.
That's right. So, our last question for today is, in the overall scheme of things, how vital is glazing as a component of building in ensuring the thermal comfort?
Well, okay. So, I mean, we can all safely say that, glazing is extremely important. I mean, I think the primary motive of bringing glazing into your house is for natural lighting. And, if we talk about windows in general, it's also natural ventilation, right? When you look at it from the perspective of thermal comfort, what usually happens is that, like I said, single glazing. If you look at a typical single glazing window, the percentage of energy losses through glazing systems can be quite high. But there are smarter ways of doing that. So, for example, while uh, windows and facades, they do contribute to 15% of the heat loss and gain. I think what we need to do is, first of all, understand how big or how much of what percentage of your building actually needs to be glazed, or what percentage of fenestration do you need to bring into your building to minimize heat loss. uh, by the way, buildings, when you talk about windows, when you talk about thermal comfort, they contribute to heat loss, but they also contribute to heat gain during summers. So we have to make sure that, one, the size of the windows respond to that, and secondly, the kind of windows that you use. So I think that is the entire crux of the discussion. So, for example, if you wanted to minimize your heat loss, what you would typically do is you would try to bring in the double or a triple glaze window system, which would minimize the heat or energy loss uh, the within your building. But simultaneously, if you also wanted to reduce the heat gain during summers, you also have solar controlled glasses, which, while ensuring that you do get natural light, but minimize the amount of heat that comes in through your glazing systems. um, I think there are a lot of interesting options available within glazing, and I think it's based on what your requirements are, and uh, what your what climatic context you work within, and the, what kind of a which building, I mean, which side of the wall you want to be actually creating a window on. I think you can design your glazing very smartly, and it ensures you the required degree of thermal comfort.
That was very informative. Thanks, Siddharth, on behalf of the entire Glass Academy and Ethos team. Uh, Thank you so much.
Thank you, thank you, thank you, everyone.